Welcome everyone to another video lesson. This is our third day on 9.3. In this lesson we're still graphing rational functions, but it's the reciprocal of a linear equation. So when you do the reciprocal of a linear equation, it turns into a rational function because then you have a variable in the denominator. Take a look at this first one. Y equals x minus 3, or f of x equals x minus 3 is a linear function. It's a line, just as you see in this blue function right there. That is a picture of the graph y equals x minus 3. Now the reciprocal, what does the reciprocal mean? It means that as a fraction, the numerator goes to the denominator and the denominator goes to the numerator. So what is the reciprocal function? We're going to call it g of x. It's going to be 1 in the numerator and x minus 3 in the denominator. And there we have it. There is our reciprocal function, which is now a rational function. So with our rational functions, we talk about vertical asymptotes, we talk about horizontal asymptotes, and we talk about removable discontinuities. However, in this lesson, there is never going to be any removable discontinuities because the denominator in our linear equation is always going to be 1. So how can you reduce anything when 1 is your denominator? So now when 1 is your numerator, you can't reduce anything from top to bottom. So there's never, ever, ever going to be any removable discontinuities in this lesson. So now that we have this, what is our vertical asymptote? It's when the denominator equals 0, which is when x equals a positive 3. So when x equals 3, there we have our asymptote. And now let's graph this function to find our horizontal asymptote. 1 over x minus 3. Y equals, parentheses, 1, close parenthesis, divided by parenthesis, x minus 3, close parenthesis, graph. There's our rational function. It approaches 3, but it never touches it. And then our other horizontal asymptote is y equals 0. It's this line right there. Y equals 0 is our horizontal asymptote. So we'll write that in our graph. Y equals 0. And there it is right there. So now, just as we graph rational functions, let's pick 2 points to the right of our vertical asymptote and 2 points to the left of our vertical asymptote. So our asymptote was at x equals 3. So here's the points that we're going to plot. Oh, slow down. Oh, rats. Here we go. Here's the points that we're going to plot. These are the 2 points closest to the asymptote on the right side, and these are the 2 points to the asymptote on the left side. So we'll graph those 4 points. 4, 1, 5.5. 4, 1, 5.5, and then the other 2 are 2, negative 1, 1, negative 0.5. 2, negative 1. Whoopsies. 2, negative 1, and 1, negative 0.5. There we go. And then let's sketch our function. Follow along the asymptotes. Don't cross over them. They approach the asymptotes. And there we've successfully graphed our reciprocal function. Now let's talk about the domain and range. This green line right here goes infinitely to the left. So it starts at negative infinity. It goes as far right as my asymptote, which the asymptote is x equals 3. So that's where it stops. But then it picks up way up here at x equals 3, just on the other side of it. And then it goes all the way to positive infinity. So our interval notation is going to start at negative infinity, and it's going to go till a positive 3. And then we're going to have a union. It's going to go from 3 to positive infinity. So x such that x is going to belong all of the real numbers except for 1. X cannot equal 3. Our range is very similar, except the asymptote instead of 3 is the line y equals 0. So this green line goes all the way down to negative infinity, so that's where it starts, negative infinity, and then it goes as high as the asymptote right here. It flattens out at y equals 0. And then right up here, it starts at y equals 0 again, and then it goes all the way to positive infinity. So there's going to be our range. It's going to start at negative infinity. It's going to go till 0, parenthesis. Union starts up again at 0, doesn't touch it, so we use a parenthesis again, and it goes till positive infinity. Which means y such that y belongs to all of the real numbers except for y cannot equal 0. And there we have problem number 1. Let's try problem number 2 altogether. We have our linear function, so to do the reciprocal function, it's going to be 1 over this, a negative 2x plus 4. And there's our reciprocal function. So let's talk about the vertical asymptote and the horizontal asymptote. The vertical asymptote is when our denominator equals 0. So when does 2x plus 4 equal 0? Well, when 2x equals a negative 4, so x would equal a positive 2 when I divide both sides by a negative 2. So there's our vertical asymptote, x equals a positive 2. Let's draw it in. X equals a positive 2. Our vertical asymptote, we're going to need to graph it, so let's take out our graphing calculators and let's graph this. 1 over a negative 2x plus 4. Parentheses, 1, close parenthesis, divided by parenthesis, a negative 2x plus 4. Close parenthesis, graph. Hopefully our vertical asymptote of x equals 2 shows up. There it is. Very good. And then once again, our horizontal asymptote is the line y equals 0. We have that going on again. So y equals 0 is going to be our horizontal asymptote. Let's pick 2 points to the right of our asymptote to sketch and 2 points to the left of our vertical asymptote to sketch. So second graph. At 2 we had our asymptote. So at right 1 up 0.5 and then 0.25. And then at 3 negative 0.5 and 4 a negative 0.25. So 0 1/4. And then at 1 1/2. And then it said at 3 negative 1/2 and 4 a negative 0.25. And there is a sketch of our reciprocal function. So our domain and range is going to be very similar to what we've been talking about recently. Our interval notation is going to be from negative infinity up until our asymptote of 2, union 2 to positive infinity. So x such that x belongs to all the real numbers, except x cannot equal our asymptote, which is 2. And then for our range, it's going to start at negative infinity. It's going to go till 0. It's going to stop at 0. Then there's going to be a union. It's going to pick up on the other side of 0. And it's going to go all the way to positive infinity. So there we have our range, and it's going to be y such that y belongs to all of the real numbers, except y cannot equal 0. Hopefully you have a handle on this now. Why don't you guys pause the video and try number 3 on your own. After you tried it, here's what you should have got for number 3. The reciprocal function is 1 over 3x plus 9. Here's the points that I plotted to the left of the asymptote. Here's the points that I plotted to the right of the asymptote. The vertical asymptote, x equals negative 3. The horizontal asymptote is y equals 0. So then here's what I got for my domain and range as well. Let me know if you have any questions on that one when you get to class tomorrow. Now we'll try this last one all together. And our reciprocal function, work with me over here for a second, class. This is over 1. So if we do the reciprocal, it's going to be 1 over 1/2 x minus 1. It can get kind of messy when we have fractions in the denominator. If we have a fraction within a fraction, it gets kind of messy. So if I multiply this by 2, I would get rid of the fraction of 1/2. And if I do something to the bottom, I have to do it to the top as well to make sure that I don't change the fraction at all. It's still an equivalent fraction. So let's multiply both top and bottom by 2. So 1 times 2 is now 2 in the numerator, and let's distribute this 2. 1/2 of 2 is 1x, And then a negative 1 times 2 is a negative 2. This looks a lot cleaner. So let's put this down for our g of x, which is our rational function after we did the reciprocal. So 2 over x minus 2. And now we can do the rest just as we did in the first 3 problems. So our vertical asymptote is going to be the line x equals a positive 2. The horizontal asymptote, when we put this in our calculator, we end up getting y equals 0. When we put that into our calculator. So here are our asymptotes. You guys can put that in your calculator if you want to prove to yourselves that it's the line y equals 0 for a horizontal asymptote. Or you can just trust me. We end up getting 2 points to the right of the vertical asymptote to be 3, 2, and 4, 1. 3, 2, and 4, 1. So your graph is going to look like this. And then 2 points to the left of your vertical asymptote when you put this in your calculator, when you look at your table, is going to be 0, negative 1, and 1, negative 2. 0, negative 1, and 1, negative 2. So then your rational function is going to look like this. So that's what we get for problem number 4. And then when we talk about the domain and range for problem number 4, it starts at negative infinity. Whoa. It starts at negative infinity. Boy, I'm just going to stop doing this. I think my orientation is off a little bit. It starts at negative infinity. Here we go. And then it goes as far right as the asymptote, which is the line x equals 2. And then it picks up again at 2, union 2 to positive infinity. So we're going to have x such that x belongs all of the real numbers, except x cannot equal 2. And for our range, it goes from negative infinity to 0, union 0 to positive infinity, which means y such that y belongs all of the real numbers, except y cannot equal 0. So that's how you graph the reciprocal function, which is really just a rational function after you've done the reciprocal of a linear function. Let me know if you have any questions on that when you get to class tomorrow.